back to Everything Mathematics, and today we're going to continue what we started yesterday. Yesterday we looked at how to plot or how to calculate our range in any given function. Today we're going to make that connection between calculating our range and of course drawing, plotting that linear equation. So we're going to graph various linear equations. In yesterday's video, we would have worked out this one. So we had the function f of x is equal to 2x plus 1, and then we had the range given as x is greater than or equal to -1, or x is, and not or, and x is less than or equal to 2. And when we work out our range, we would have gotten this. So I'm not going to work it again. If you want to see how we work it out, you could look at yesterday's video. And we got these values in. And today, I simply want us to draw these values on our, well, our mapping, our coordinates, our graph paper right here. So let's see how we look in here. So I'll just have to do a little labeling first. So remember, this is my x-axis, this is my y-axis. And the values here are very small, so I could actually label them 1. Let me see. I'll use 2 square units for 1 unit. Let me see. 1, 2, 3, 4. Nope, it wouldn't work. So I'll use 1 on the y-axis. So 1, 2, 3, 4, 5. I'm not reaching as far as 5. And on the x, I will use 2. So I need -1, 0, +1, 2, 3, 3. No, I'm not even reaching as far as 3. So it's -1, 0, 1, 2. So I don't need 3. I don't need 3. But again, it's always, when you don't know what the graph will look like, you will want to put all your values because you don't know where you would end up. And here I am using a different scale on the y-axis to the x-axis. So on the y-axis, I'm using a 1:1 scale. On the x-axis, I'm using a 1:2. So every 2 units on the x-axis is 1 unit. So 2:1, but every 1 axis in the y-axis is 1 unit. And I hope you notice that. So I didn't skip this on purposeful. I skip it purposefully. So I know that, so for those that might be thinking, no, it's supposed to be here, and it's supposed to be here. No, I did it like that so my graph wouldn't look too jam up. But don't worry, so in mine, algebraically speaking, I would have a stretch. It will stretch because I stretch the x-axis but not the y. So it wouldn't be too literal, it wouldn't be too plain, but whatever. Good. So let's plot this. So when x is -1, y is -1. Oh no, I need -1 on the y too. So I didn't go down to the -1. So for the -1 on the y, let's keep it here. I should have stretched on now, but I can't stretch the y because if I stretch the y, I wouldn't make it on 5 at the top. So this is -1 here. That's okay. It wouldn't hurt us. Right. So -1, 1. So -1 on the x, -1 on the y. -1 on the x, -1 on the y. That point will be right here. Hope you can see my blue dot here. Then we have 0. When x is 0, y is 1. So that will be here. And remember, you see this 1 here? That is our y-intercept. The function told us that before we actually even work it out. Good? Then when x is 1, y is 3. So x is 1, y is 3. And I hope you all seen the line already. Because remember, it's a linear equation. So we're supposed to get a line. With 3 points alone, we could see the direction of the line. And when x is 2, y is 5. And that will bring us up here. Right? And of course, with a ruler, if you have a ruler, you should be drawing this very properly, very prim and proper. But I don't, so allow me to sketch, and my line will look something like this. Yes, my line looks something like that. But remember, it's supposed to be straight. Don't take my wobble example as that. I am sketching, and I can't help it for now. But yes, this is supposed to be a straight line, as straight as it could be. Or we could say a line segment because of course this point runs like this and this point will run this way until eternity, right? So we have a line segment here and that is how we draw our line. Yep, and that's basically wrapping up what we did yesterday. Let us do a new one today and see how we could come about it. So here today we have this inequality. So we have a new function. We have f of x is equal to 3x minus 2. And then we have x is greater than 1. So notice here, x is greater than 1. So x cannot be 1. So the lowest value for x would actually be 2. And then they say that x is less than or equal to 5. So the highest value for x would be 5. So that means x will be 2, 3, 4, right? And then 5. Yep, that's our values for x. So let's just quickly calculate those values. So remember, we're just plugging in x for y in this function and we get y. So quickly, when x is equal to 2, so when we have f of x is equal to 2, we will get a value of y of 3 times 2 minus 2. And this will give us 6. 3 times 2 is 6. 6 minus 4. Well, let me write it there. 6 minus 2. And that will give me 4. Good. Then, so when x is equal to 2, y is equal to 4. I'll write it all just now. When x is equal to 3, we will have 3 times 3 minus 2. So that means that x will be 9 minus 2, which is equal to 7. When x is equal to 4, we will have 3 multiplied by 4 minus 2 equal to 12 minus 2, which is equal to 10. And when x is equal to 5, we will have 3 multiplied by 5 minus 2. 3 times 5, that is 15, minus 2, that's equal to 13. So these are our y values for the various values of x. And this is what we have right here. I just showed you how to work it out, right? So when x is 2, y is 4. And by the way, we have to be very careful here, because if we cannot read the range, mind you, you already will be getting the question wrong. Because if you add in a value that's not supposed to be there for x, then you might be either going, oh, well, let me not say you're getting it wrong. You may not get it wrong, but you would lose marks. Because if I'm grading you, if I'm testing you to understand if you could read the inequality, and you put in a value that should not be there or may not satisfy this inequality, yes, you're going to lose marks. Not that genuinely you're wrong, because in reality, as I said earlier, x could have any possible value. But in a given function, sometimes they just want you to calculate a given range and not any and any value of x. So that's why you have to be careful. But yes, going back to what I was saying just now there, when x is 2, y is 4, or f of x is 4. Remember, f of x is the same as y. When x is 3, y is 7. When x is 4, y is 10. And when x is 5, y is 13. And look at, we work out all this right here. So we have check, 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 check. So it's not rocket science. You could actually work it out. And now we could plot our graph. And again, we ain't draw it yet, but we know this is a linear equation. So we know it's supposed to give us a line. So our points supposed to connect to form a line. Let's see what scale I would use here. Ooh, I'm going as far as 13. So let me see. I want to use 10. Okay, so I could use 5. 5, 10, 15. I will have to do a little guessing, but that's okay. And on the x, I'm only using positive values. So I will go, let me see, 2, 3, 4, 5. Okay. So I'll use 2, 3. Nah, this ain't gonna make sense. Let me see. Well, it doesn't matter. Well, yeah, this would be 1. So it will be 1, 2, 3. Yeah, keeping it same. 3, 4, and 5 here. I make up a kind of scale here because again I want my numbers to fit. I will have to do a little approximating and guessing because of the coordinates on my y. Yes, it will be a little iffy, But bear with me, bear with me. So we know here go be, see that's where it gets tricky. This half point here is 7.5. Yeah, and this half point here is actually 12.5. So I'm working with those kind of estimations there. Don't mind, but don't worry, I won't guide you wrong. Good, so where do I go? So when x is 2, y is 4. If this is 5, y would be slightly below that. So let's put it somewhere there. And again, that's what I was referring to when I said I had to do a little guessing. If I had a grid, well, I have grid, but if I have a graph paper, you know, in them real graph paper, well, not real graph paper, but you know what I mean. Then graph paper actually have a grid for every little millimeter. So you could actually count 7 and 4 and all them odd numbers that wouldn't show up exactly on your main grid. But here I don't, so I just do a little guesstimation. And believe me, I'm good at estimating, so don't worry. 3 and 7. So when x is 3, y is 7. We know here is 5, we know here is 7.5, so 7 will be somewhere around, let's say here, give and take, just below that little marker there. And well, 3 on the x. So the x will be very accurate, but the y, I will be doing some guessing. Oh, well, not for 10 for sure, because 10 is exact. So when x is 4, y is 10, and we could see 10 is right here. Good, 10 is right here. And when x is 5, yes, I'll do that little guessing here. So 13, remember, is like 12.5 is like here. So 13 would be a little above that mark B. And even with my little guessing, you could see semblance of a linear equation. You could see the semblance of it, don't you? Can't you? Yeah, man, you could. And here you just connect all these points here. Yep. And again, if you're using a ruler, remember this is supposed to be more accurate. Not more accurate, it's supposed to be straight. Not accurate, it's supposed to be a straight line. But because I'm not using a ruler, yes, this is how mine is looking. So, this will bring us to the end of today's video. I trust you honestly understand how to plot a graph, a range. If you don't get it again, feel free to comment. I will gladly do over another question. So until the next time, like, share, and subscribe. And of course, comment if you don't understand and turn on your notifications so you'll get your next video on Monday. You do have an enjoyable weekend. Until then, you take care. Alright, so it's not often, of course, that people stick on to the very end of a given video. So today we have this special one here. Today's a birthday of a very special someone in my life, and here it is, none other than my baby sister, Davina. So again, this one is for you at the ending of this Everything Mathematics video. Your day, I trust that your day is going good. And if you do watch this one to the end, I hope I surprised you. So you do have a happy birthday. And here is your message. Happy birthday to the best sister anyone could ever have in this world. Love it to the moon and whatever is further than that. And definitely with no return. You know, people somebody say they love it to the moon and back. But we ain't coming back. We're going until infinity. All the best. Espero que te guste mucho. Do enjoy your day. Later.